Hello and welcome to the most magical show in the keyboard community. I'm your host Merlin, and today we are going to be porting the 1UpKeyboards Super 16 Macropad into Qmk. But before that, hello to my current 9 watchers. Thanks for joining me on this wonderful adventure. Thanks for taking your time on this beautiful Saturday just to watch another stream. But let's see who's on today. Hello, Boy314. Hi, Cyber Sam. Hello, Dat Weapon. I like that name. How are you all doing today? Hope you have time to watch the stream for 2 hours because it's probably going to take that long. But let's see. I normally try to do 1:30 on Saturdays, but today just kind of got hectic. I got trapped in Costco. We were preparing for Super Bowl festivities, and my wife saw a bunch of hangers that were really cheap. So we were considering if we should buy them or not, and after like deliberating back and forth, we were like, no, we should totally buy these. So we bought 4 packs of 50 hangers each. They were $10. On Amazon, these same things were $27 for a 50 pack. So we just jumped on it. But let's see. Anyway, enough of that now. We are going to be porting the 1UpKeyboards Super 16 today, which I have right here, courtesy of Ski with Pete himself. He actually does streams too, so if you look up his channel, he does a bunch of build logs, I think. But this is the Super 16. It's in a Sweet 16 box that's just been crossed out. That's the PCB. And it came with a bunch of other stuff. No. Okay, but to give you guys a better view of it, let us move to the product page. These things are $10, so they're really cheap. The difference between the Super 16 and the Sweet 16 is this one actually has Rgb Underglow, and I think he calls it only for experienced builders. Consider this for the elite only. And it's $10. You can buy switches, which of course add to the price. The Pro Micro is another $7. Standoffs, diodes, yada yada. So probably $30 out the door. I actually thought that this keyboard was already in Qmk, but apparently not. So we are going to put it in today. And this one's going to be a little different stream. If you've watched my other streams, I've also done Qmk porting, but it's always been with the assistance of a kbfirmware.json file that goes into something like this. And basically, kbfirmware is pretty cool because it tells you all the pins. It tells you oh gosh, that looks ugly. But yeah, it tells you the wiring of the pins. It tells you how many RGB LEDs there are, and a bunch of other stuff. But what if you don't have a KB firmware JSON? What if all you have is a PCB? What do you do? We are going to figure that out. So without further ado, well, actually, before we go into it, we probably need a little bit of learning. Okay, to do this, you're going to need to use a multimeter like the one I have here. This one's a fairly cheap multimeter. I think I picked it up for $10. Doesn't do much really other than check for continuity. Yes, we are tracing today. Thanks for joining us, Rgb. So before we trace this concept of tracing, like I need to explain how this works first. So to do that, we have a schematic here, courtesy of the great Ruchi Mao. If you look him up on Google, he has this great PCB making article that you can follow through. Basically, this is the schematic. You do a 2x2 Macropad, you connect it to an Atmega 32U4, and he walks you through the PCB process and you eventually should be able to print out this PCB and have it fabricated. But okay, let's start. So what I'm looking at here is the schematic of that PCB. What these things are, K1, K3, K2, K4, this represents your typical switch. And they have 2 points. Each of these points represent each of the legs on your switch. What these are diodes. And this thing over here is the microcontroller. And all these wires that you're seeing here is how all of these switches are connected to the diode and how they're connected to the microcontroller. So we're going to explain how tracing works. When you're tracing a matrix, you want to see how each of these switches are connected. So basically, you would take your 2 leads, like so, and put them on 2 points. And you're basically looking at each of the wires. So you would look at this wire here. You would look at this wire here. So let's see. You would need to look at your columns and your rows. Audio is kind of low, says Boy. Let's see if I can do something about that. How's that? Oh, that's starting to clip. Hello, hello. Test, test. Okay, that looks better. All right. Okay, so where was I? If you want to figure out the columns, basically one of these legs will be a column leg and the other leg will be a row leg. In this case, you can see that one leg of switch K1 is connected to the other leg of switch K2. And this entire line right here is connected to a pin designated as column 0, which happens to be pin F4. So basically, if you want to see that these switches are connected, you would put one of the leads on this guy right here, and the other lead on this one. And if your multimeter beeps, this connection works. So you would do this for this column, column 1, column 2, column 3, so forth and so on. So for a small board like this, that's a relatively simple process. But if you have something like a 96-key keyboard like that, it's a very long process. So, which is another reason why I'm only doing a Macropad today. So once you know the columns, you can do something similar with the rows right here. So you can see that switch K1 right here is connected to diode D1. And diode D1 is connected to another diode called D3, which is connected to another switch called K3. And all of these diodes that are connected to each other are also on the same row, which matches to pin F0. So I like how he's labeled this, so you know that row 0 matches with row 0, row 1 is with row 1. So to trace this, what you would do is you would once again take one pin. Well, okay, this is going to be a little different than the column one. This was just literally one lead here, one lead here. But this one, you have to make sure you have to find the diode that's connected to the switch. So by doing that, you take one lead, you put it here, another lead over there. And then once you know that, then you can figure out each of these diodes right here. Hopefully that's clear with everyone. The pins printed on the silk screen. Yes, it is. It definitely is. But we will still be teaching people. Okay, so let's begin. Okay, so one thing to note about the Super 16 is that it uses a Pro Micro. And I've seen a lot of people not connect this properly. Let's see, where's my Pro Micro? That's not it. there it is. Yeah. Okay, well, it's sealed right now, but we are going to move. There we go. Let's try this. Okay. So as that weapon was saying, this is the PCB, and it conveniently actually has the row pins and the column pins all laid out for you already, except it doesn't have the RGB pin. So what we're going to do is figure out how each of these guys are mapped to the Pro Micro. The interesting thing about this Super 16 is that the Pro Micro isn't placed directly on. It's actually flipped upside down and then placed on. So instead of this pin over here being D3, it's actually raw. So that's raw, that's D3. That's D2, ground, resets, so forth and so on. So we are going to pretend, can't you do the second pin of the switch directly with row 0, says enemy's friend 22. The second pin of the switch. You mean like the second pin of the switch directly with row 0? You mean this pin? It is part of row 0. Except it has to connect to a diode first before it's part of the row. Like you can have diodes on the row or on the column. Really depends on the designer. For this particular design, the diode is on the row. Hi, Qmk Gaming. Thanks for joining. Sorry if I'm butchering everyone's names. I'm trying here. Okay. So what were we going to do? Yes, we were going to... Okay, let's see if I did this correctly. Tracing, there we go. Okay, so I have to move my webcam because I only have one webcam. And we are going to make it, yeah. Okay, there we go. Okay. Okay, so first things first, turn on your multimeter, and I like to hear it beep because I don't like having to trace it and stare at the screen, because sometimes when I look at the angle, it's not very viewable. So I'd rather turn it to beeping mode. So to check that it's actually beeping, I like to do, yeah. Okay, so what we're going to do is, going back to this diagram over here, I'm going to try and figure out where the columns are first. So my guess is that this guy right here, this is one entire column. So I'm going to put one test lead here on this hole, and just put the other one there, and there. And if it beeps all the time, then I was correct. There's one. There's another one. So let's see if this column extends any further. Nope, it doesn't. What I just did there was I just tested to see if this hole was connected to that. Well, and I tested all of them pretty much, and all of them did not. Currently, only this column actually beeped. Okay, so now now that I know that this is one column, I have to figure out which pin on the Pro Micro it connects to. And according to this, it says column D4. But we're going to ignore that right now. So what I'm going to do is I'm going to put one lead there, and my other lead, I'm just going to go through each of these holes until I hear a beep. So like so. Can't you do the second pin of the switch directly with row 0? So it's enemy's friend 22. No, it will not beep. Okay, so we're just going to go through. Doot, doot, doot. No beeping yet. Oh, there we go. So that's the 1, 2, 3, 4, 5. The 5th pin from the bottom. So as you know that this is upside down on the Super 16, we're actually looking at this side instead of that. So that's 1, 2, 3, 4, 5. That's F7. It's actually that one, that column. No. 1, 2, 3, 4, 5. There we go. Yep. That's F7. Okay. So now we're going to repeat this process for each of these columns. So this next one should also be its own column. Yep, that is its own column. And it should be F6, but we're just going to go through each of these pins again. Oh, it's my favorite Korean streamer. He's my favorite Korean streamer because that's what his Discord channel says whenever he streams. There we go. Okay. It's 1, 2, 3, 4, 5, 6. It's the 6th one. So 1, 2, 3, 4, 5, 6. F6. And what do you know? It's correct. F6. F6. Okay. Now we're going to look at this 3rd column over here. So, let's see. Basically the same process over and over. Okay, beeped 4 times, or 3 times. This is one whole column again. So next we have to find the pin. No one's beeping. Nothing beeped when I marked against this side of the Pro Micro, so it has to be on this side. Actually, I like have that upside down. 1, 2, 3, 4, 5. 5. So 1, 2, 3, 4, 5. C6. And yep, that matches it. Okay. So for the sake of brevity, we're just going to assume that this is correct. It is, and this entire column is connected to D4. Okay, so now that we know the columns, that we verified that this guy is correct. Now we have to look at the rows. How you check for rows is, let's go back to our little, yeah, it's over here. We have to search for this connection first. So in this case, it would be from the other leg to this pad of the diode. So let's just verify that. Yep, there's a connection that exists from this leg to that pad. So now we just want to verify that this is its own row, these 4 switches. So basically, that has to connect to another diode. There's a connection from this pad to that pad over there. And just to verify that this pad is connected to this switch, I'm going to check for this connection right there. I know the PCB is black and my mouse is also black, so sorry if you're all squinting. But here we go. There we go. Okay, so these two switches are connected and are part of the same row. And I'm just going to do the same process throughout the rest of them. Okay. I verified this is all part of the same row. So now I need to find out which pin this row is connected to. Once again, you can look at the row pins. It's F5. But to do that, we are going to, let's see. We are going to put one lead on this pad here, and the other lead we're going to comb through all of the pins. So it actually doesn't matter which of these four pads that you put the lead on, because they should all be connected, and they should connect to a pin on the microcontroller. So here we go. I'm combing through each of the pins. For all of you watching, feel free to ask questions. The purpose of this stream is to show people how it's done. So questions about the subject or questions about keyboards are all welcome. Aha, I found it. Okay, so that's the 1, 2, 3, 4, 5, 6, 7, 8. It's the 8th one from the bottom, and it's on this side. So it's 1, 2, 3, 4, 5, 6, 7, 8. D1, which is right there. Great. So now you repeat the same process through these next 3 rows. Basically, you would make sure that this is a row, and then you find which pin it's connected to, and it's the same thing 2 more times. Yan says, nice Clacktober t-shirt. Yes, I do. I'm very proud of it. So, well, if any of you are not familiar with Hacktober, Hacktober occurs in October, obviously, and if you do 5 open source contributions, I think, into GitHub, into anything really, it could be a PR of like a document change or anything. Actually, I think it's as long as you open a PR, it doesn't matter what kind of PR. It doesn't even need to be merged or accepted. It counts towards your 5. So this coming October, if any of you want to commit to open source projects, my favorite one is Qmk. So contribute, and you might get a shirt as cool as this. Can you explain what the diode is doing, why it's needed, says Enemy's Friend. Okay, here's the thing. So if you have all these switches connected to each other, and you know, it works just fine. Like the microcontroller is able to tell if you pressed K1 or if you pressed K4 or K3 or K2. The microcontroller will register that just fine. But what happens if you press K1 and K2 or K1, K3, and K4? There's a problem there. Like, how does it know like which one registers, or do they register both of them? Or like sometimes what happens is if you press K1 and K2, maybe it mistakes it as K3. That's the purpose of the diode. This is what ghosting is about, and what people desire. Like they want NKRO, where N is like the number of keys that you can press. So that's why we have diodes there. It's also dependent on your matrix, because, okay, so this is a little more advanced topic. So the reason why you want these diodes here is because you have a 2x2 matrix. If you had a 4x1 matrix, where there was only one column and 4 rows, the microcontroller would never be confused as to which key you're pressing, because each key, even though they have the same column, they have unique rows. But okay. So for the people just joining in, I have traced this entire PCB, and I've confirmed that this is one row, one row, one row, one row, and this is one column, one column, one column, one column. And I figured out all the pins that they're mapped to. So the next thing to do is to, yes, RGBs. But before we go into the RGBs, just want to go off on a little tangent here. So how many people here have had issues with desoldering? Like I remember when I first got my first mechanical keyboard, it was a KUL ES87. Well, it's not my first mechanical keyboard, but it was my first modern one. One of the switches died, and I had to replace it. So when you replace a switch on a board like that, you have to desolder the switch. And on most OEM boards, the solder used for it is lead-free, which means you also have to use higher heat when soldering and desoldering. If you are not adept at this process, you could very well burn off these pads which the solder adheres to. Oh! I think my multimeter's dying. Let me turn it off for now. Okay. But yeah, you could very well burn off these pads that the solder adheres to. And once you do that, even if you solder the switch on and it looks like it's connected, what happens is you break this connection. So even if you programmed it, no matter how hard you press on it, it's not going to register. So to understand what happened is, if you've been with me since the start of the show, this particular column, well, it's part of column 2. So this pin is connected to this pin, is connected to this pin, is connected to this pin. And if you burn off this pad, if you put a lead here, and you put your other lead here, there's no continuity. Because it can't find it. So what you can do to fix that is take a piece of wire, solder it to a leg here, and solder it to the leg here. And you'll finally be able to register this switch. The smell of burnt PCB in the morning. Thankfully, I have not smelled that often. Okay, so what do you do with this information? You put it into Qmk. So now begins the coding part of this tutorial. Okay, so no more need for that. I can come back to this later if people... Oh, there we go. With the wire, I missed the mouse. What do you mean you missed the mouse? Is it because you can't see it? Okay, well, I can explain that again with the schematic. Okay, so if you burn off a pad where one of these switch legs are, like for example, if you burn off this guy right here, you essentially destroy this column connection. So when you press this switch, nothing happens. When you press K1, nothing happens. You need to rebuild this line here with a piece of wire. Or like the more troublesome one is if you burn a row pad. because some soldering wires from one switch leg to the next isn't very difficult. But when you have to solder it from a switch leg to a diode, like if it's a surface mounted diode, that's a little more difficult. Shade Dream says, wait, that's not HML. What's HML? Hannah Montana Linux? Oh wait. Shade Dream, you did not miss the stream. I just finished tracing this, and I was just going through schematics, but we are about to start Qmk. Okay. All right. So now with that information we have on hand, we know the pins, we know the columns, and we know, actually no, we don't know the RGB yet. So let's go back to that. I forgot the RGB, guys. The most important one to trace. Okay. So what we need to know is most people use the, I think it's the WS, yep, there it is, 12B. There you go. Here's a good diagram right there. Let's make it big, like so. Oh, it's actually already on the stream. Okay, so basically, you need to be familiar with each of these LEDs. Each of them have 4 pins. One is VSS, one is VDD, one is D0 and DI. So D0, or actually it's a DO, it stands for data output and data input. So these are connected by, like if you had 2 of these guys, it would go DO to DI, DO to DI. So if you wanted to do that, where are we? Okay, here we go. So that's the D0, I mean that's the DO pin, and that's the D input. So we have to figure out, well, we just have to figure out the pin that these guys are connected to. We don't necessarily have to trace how they're lined up. But why don't we do it? So I'm going to put one lead on this guy and the other lead on that one, because it goes data output to data input. And let me turn on my multimeter first. Okay. There we go. There's a connection from data input to data output. So next we have to figure out the data input, and does it connect to this one or that one? Does not connect to the one immediately below it, but it connects to the one to the left of it. So rather than going through all of them, basically I already did this before the stream, and the way that these guys are connected, it zigzags. It goes that way, it goes down, that way, goes down again, that way, that way, that way. So the 2 terminal ones are this guy and this way. So to find the pin that this is connected to, you have to put it on the data input of this guy right there, because the microcontroller is sending a signal to it right there. So you put one lead there, and you get to go through all of the other pins and figure out where it is. Okay, it corresponds to pin D3. So RGB, the string of RGB lights is connected to pin D3. Hi, Ted. Waves goodbye. I have to go run some errands. That's what I did this morning. Ted is a Washington neighbor. He's kind of far, but he's still kind of a neighbor. Okay, so we know that RGB is pin D3. It's funny that he noted all the other pins, but not the RGB. Okay. Okay, now we can actually start coding. Okay, so I like to remind people that when you start off coding QMK, you don't have to start off from scratch. Let me adjust my camera here. Okay. Yeah, you do not have to start off writing everything from scratch. We actually have scripts that do that for you. You can find that script in, let's do Ranger. You can find it in Qmk Firmware util directory, and it is called new project.sh, like so. So what you want to do is run that script. New, no tab completion until you're in the right directory. Yep. New project, and typically here you write the name of the keyboard, but you don't want to just write Super16. The reason being is because there is a directory for 1upkeyboards. So you do not want, so you want to create this keyboard in the correct directory. In that case, you do 1upkeyboards / Super16. And when you do this, it auto-populates it. Okay. And look at all these new files. So pretty. You don't have to write any of these yourself. Okay. All right. So hopefully everyone's been following along with the tracing. That was what I started at 2:30. That took about half an hour to do. Given I was explaining as I was doing it, but even a small Macropad like this took 30 minutes. Imagine something like that. Yeah, so for everyone just tuning in, this is a QMK port. I've been doing it regularly. There seems to be a lot of keyboards out there that are not in QMK or just have not been like actually submitted in. This one I actually thought was already in since we have a lot of their boards, but I guess not. If you've missed the first half of the stream, don't worry. You can find this on a VOD, and I will be doing more tracings. But this might be the last Macropad that I trace, just because I don't buy Macropads very often. So the future ones might be longer. But thank you for watching, guys. Hope you guys stick around for the actual QMK programming portion. Okay. Oh, yes. And if you like what you're watching so far, I gotta show my channel, you know. You can catch me on youtube.com/MacMerlin. I've got an Instagram account, also MacMerlin, and on Facebook as well. If you like this stream so far, please, please, please send a donation to streamlabs.com/MacMerlin. I'll actually put that in right now. streamlabs.com/MacMerlin. And yeah, stick around for the next portion of the show. Tefren34 says, hey, you made it! He says, really? Up isn't in QMK? Well, 1upkeyboards is in QMK, just not the Super16. All his other boards are in, especially the soon to be released 1up60 HTE, but I don't know why this one isn't in yet. But anyway, I just generated a template for our Qmk, and you know, it's a template, so it's not going to be 100% what you want. So the first things first, you want to, well, I'm just going to do initial commit right now. Sweet. Okay, you just want to go through each of these files and get rid of all of the vanilla stuff, like, you know, for example, I prefer my name being 2 capital M's for Mac Merlin. And I'm just going to go through each of these files and just copy paste, copy paste, copy paste. Okay, and once I've done that, I like to start with the Readme. So, let's take out the image there. Give it a good description. A 4x4 Macropad with Rgb Underglow. Keyboard maintainer. Yeah, once again, feel free to ask about this process. Any questions are welcome, even about keyboards. Tefram34 says, so as long as you have the pinouts, you can import it into Qmk. Yes, the pinouts and the matrix. So that's what I was doing the first half of the show. I took a multimeter right here, and I traced not only the pinouts, but how each of these switches were connected to each other. Okay. Hardware supported. Super16. Hardware availability. 1upkeyboards. Okay, let's grab that link. Super16 Macropad. Actually, it's called a Super16 Macropad. Let's call Macropad. And here's a gotcha right here. Make sure you put the directory that it's in. Okay. So readmes are a bit tricky because if you don't put the right spaces, it ends up looking like this. Hardware support at Super16 Macropad hardware availability. You need two spaces to make it render properly. There we go. Okay. So after the readme, I like to look at config.h. Config.h is where you define like the size of your matrix, what pins you use, and yeah, all this good stuff. So let's change that. We know this is a 4x4 matrix. We do this, 4x4, manufacturer, 1upkeyboards. I don't think they actually manufacture it, but they are the vendors. A 4x4 custom Macropad. You think, yeah, I got 1upkeyboards. Oh, are you talking about the Readme? Yes, you're right. Yeah, there we go. Okay. Oops. And we know what the rows are, but as always, I have forgotten. The rows go D1, D0, F4, F5. And the columns actually were different. It went, because we're doing it this way. Those are the rows, and columns start off like this. So it starts at F7. Actually, just because I'm paranoid, just going to double check that. Yep, F7. It's the other way around. F7, F6, C6, D4, C6, D4. TechFrem says, yes, at least you have it printed on the silk screen. That weapon says, correct me if I'm wrong, but it doesn't have Rgb Underglow by default, but support for it. It does have per key RGB though. No, that's not what's on the feature list. Actually, now you have me second guessing things. Let's read the feature list. The newest iteration comes with surface mount RGB LEDs for you to install and program. An RGB LED ring to mount on the bottom of the PCB to give you underglow as well. This is a single PCB that contains no soldered components. Actually, not compatible. That's interesting. With surface mount RGB LEDs, that doesn't necessarily mean that it's in switch, especially since we actually traced it. We actually traced it and showed that this is a typical Rgb Underglow configuration because all of these guys were connected and connected to a single pin. It's an underglow connection. Like if it was actually in switch, there would be I think you would need a MOSFET. But there are no positions for a MOSFET anywhere here. I'm pretty sure it's underglow. Okay. It's per key. So that weapon, can you actually change the color of each RGB? Because it's in an RGB Underglow configuration that's just mapped per key. Those are two separate things. Like you could take all your underglows, like this board here. Actually, let's change my, there we go. Yeah, you could take, there we go. You could take each of these underglow RGBs right here and put them in per switch. You would just have a really long string of RGB underglow. It's added after them in the chain, but it's only connected to a single pin on the PCB. I don't see how this is actually RGB per switch. It's an RGB underglow that just happens to be put into each switch. Let me look at that PCB for all to see a little bit more. Yeah, this looks like for that ring. I think that's like, that's really weird. Okay, I'm actually gonna see where these guys are connected to on the microcontroller. Okay. Oh, that's funny. Okay. LED is connected to the same pin that the rest of these underglow RGBs are. I think it's the same backlight pin driving the in-switch RGB and the RGB Underglow. They're both it's the same implementation of Underglow, just one is made to look like it's in-switch. It's the same pin. Okay, so let's see if I can explain that. RGB Underglow is usually a string of RGB LEDs using the WS12. I forget the number. This guy right here, the WS2812, and basically they're all stringed up together, and so D0 goes into DO goes into DI, and it goes like for as many as you want, and eventually the DI is driven by a pin on the microcontroller. So that's how Underglow works. And on this particular board, you have the in-switch RGBs driven using an Underglow methodology. And they also have another Underglow ring, which I think I actually have in here. Oh, here we go. You have another ring. And it's actually connected to here as well, which happens to be connected to the same pin that's driving all of these. So yeah, this board has RGB Underglow. It's not per switch RGB as like an HS60 per se, or a ZL60. Well, actually, even a ZL60 is not completely per key RGB. Okay. Now we have solved that mystery. Okay, so I have created the matrix row and the column pins. And we want to... So there is no backlight. There is no backlight at all. It's all just RGB. And... okay, we don't need that. We don't need that. Let's comment it out. What pin did I say it was? D3. 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 And there are 16 of them. Though I guess that number changes once you add that ring in. I'm going to put a comment. Okay, I'm going to open this guy up. Yes, I need to show the screen. Okay. Right. So as I was saying earlier, we don't have any backlight. It's all just all underglow, and it's at pin D3, and there are 16 physically on the board. Well, if you solder it on. And if you put the ring one on, this guy right there, that's an additional 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's an additional 12. I'm going to comment that. Add 12 if attaching the ring light. Is that what it's called? A ring light? RGB LED ring. There we go. Attaching the RGB LED ring. There we go. Okay. Looks good. Okay, that should be all you need for the config.h. Next up, you need to modify rules.mk. Rules.mk is where you turn on a bunch of Qmk features, and you can find them all on the bottom. Boot magic enable. There's... Okay, Rgb enable needs to be turned on. And we are going to set boot magic to light. Like so. And anything else we need to do here? Nope. Okay, now comes the fun part. We get to create the actual switch matrix. So this is called a layout macro. And that's why we call it layout. If you have seen other versions of Qmk, especially ones from maybe like a year and a half ago, actually you'll still see it in some of the code right now, but sometimes you'll see this as keymap. That's not technically correct, since it's a layout macro, so it should be called layout. And the way we format this is we have like layout underscore some description. A 4x4, I think is, I know we have a default for that. I think it's ortho something, but I'll look into it later. So the layout macro consists of two parts. Two parts. This bottom part right here is the actual switch matrix, and it's very sequential. You have like K00, 01, 02, 03, and then this top part right here is how each of those switches are laid out physically on a board. So these numbers here, the first one designates the row, the second one designates the column. So for example, K10 is the switch located in the switch matrix in row 1, column 0. And this is row 1, column 1. So we can start by creating the switch matrix. This is very, very sequential. I have to copy and paste it. It's like the simplest part of creating that switch matrix. Oops. Okay. So if you're really lucky, or if the designer was intentional about it, the switch matrix is or the physical layout here is arranged just like the switch matrix. And basically you could literally just copy and paste it. But in some cases, let's go to a good example here. In some cases, such as the bface by winculus.kr, see, this is the switch matrix. It's all sequential, K01, K11, K21, K31. But the physical layout, K00 is not on the top left. It's somewhere else. So it's down there. And in even other cases, like the ALP 64 made by Hasu, you have this. It's also sequential. It's an 8x8 matrix, but the actual physical layout is a 15 by 5. So it's not always going to be copy and paste. But in our case, where's my screen? Here we go. It can be copy and paste, but let's just do this. K11. forget to add commas. Yay. Okay. So when you're looking at this, you have to look at your config.h again. And look at your row pins and column pins. These guys are in a particular order. This is row 0, row 1, row 2, row 3, column 0, column 1, column 2, column 3. So if you have something like K00 at row 0 and column 0, that would mean this particular switch in the top left of the PCB right there is connected to pin D1 and pin F7. And just because I'm paranoid, I am going to double check that. Yep. D1, okay. And D1 would be somewhere here. Yep, that is correct. No comma after the last one. Where was I looking at? Oh yeah, here we go. Yes, no comma after the last one. Well, actually, I don't really know. I guess I'll find out once I actually try and make it. But let's clean this up a bit. Like so. And after you've done this, next up is to do the key map. I know, what do people usually do for Macropads? Numpad 4x4. Okay, so when you make your key map, typically speaking, some keyboards will have multiple layouts, and you need to pick the layout macro that best suits your physical layout, and these names have to match. So speaking of matching names, Qmk has a bunch of default layouts that just so, like, for example, a board such as this. Board such as this, it's your typical 60% ANSI that you see on most 60% sold by factories. Like, just so people don't call it layout 60% ANSI or layout 60 standard or layout 60 whatever, we've tried to come up with more standard names. So we can search through the Qmk repo for what a 4x4 all 1Us are supposed to look like. So I would assume it's ortho underscore 4x4. You know, why don't I just use this? Actually. Okay, so now that I've changed it in the key map, I need to make sure it matches everywhere else. Okay, key map in there. Okay, that's good. There was a numpad 4x4 as well. I don't know what a numpad 4x4 looks like. Let's look. Numpad 4x4. What is a numpad 4x4? Okay, so this is a KLE layout. We can check out to see what it is. Oh, okay. So a numpad 4x4 is like that. Okay, I just want it all one U key, so it's going to be ortho 4x4. But let's just double check that ortho 4x4 is what I want. Boom, yep, ortho 4x4 is indeed what I want. Okay, I think I'm done. Well, I'm done with making the key map. There are other things to do. So let's attempt to compile this guy. Super16. Add layers. Okay, well, I'll try and build this first. Woo! Pass 17 arguments, but takes just 16. I have one extra guy in there. Do I? That's not right. What am I missing? I always miss something here. Is it because I put a comma? Might be. Let's try. Yeah, there we go. It was the comma. Okay. Okay, it's a really boring key map, but sure. Okay. So this is all well and good, but right now this is only usable for people who know how to set up a Qmk environment or are on Linux or on Mac OS. Like doing this, getting to this point is very significant if you're on Windows. You have to set up MSys2 and all that, and not everyone wants to do that. Good thing we have a new tool called Qmk Configurator. If you haven't heard of it, it's at config.qmk.fm, and it looks like this. It allows you to put in your key map, like so. But this is about to change. We are currently doing a beta. Where all of the key maps have been tabbed. So basically, we want to put in support for this so other people can do the same. And the way to do that is all in the info.json file. To do this, we have to go back to Keyboard Layout Editor. And if I did not throw away my previous one, here we go. Yeah, we can take this code, this raw data there, and throw it into qmk.fm/converter. If you're just following along here, I will have all these links in the VOD or on YouTube because I've been posting my videos on YouTube as well. You can take that raw data from the Keyboard Layout Editor, copy and paste, hit convert, and boom. This is the text that you want. Copy and paste it back into info.json, and oh, that's interesting. Thought I fixed that. And give it an appropriate name, Super16. Okay, so here we go. We need to make sure that this name right here matches this guy, and it matches the key map as well, if you choose to use that particular layout. So we are going to name this layout underscore ortho underscore 4x4. Okay. So you can't really test your info.jsons unless you set up Qmk Configurator on your own. But there is a quick way to make sure that your layout is indeed correct. So since I copied this from Qmk, I'm pretty confident that I have it correct. But to do that, to be absolutely sure, go to config.qmk.fm, hit the magic combo Control plus Shift plus I. It brings up a dialog box like so. Navigate to that info.json that you just created, Super16, and if you open it, it should look like what you did in Keyboard Layout Editor. So open, bam, looks the same, looks great. You now have Qmk Configurator support. Hooray! Okay. So that's what it takes to port into Qmk Configurator and into Qmk. So that took, I started at 2:30, it's now 3:44, roughly an hour to do a Macropad. Of course, I was talking most of the time as well and double checking my work, but that's the time investment that you could expect to take. I know I always bring up this board. 96 key will definitely take longer. In fact, I've been working on this board and it's taken me months. It's taken me months because I kept second guessing my matrix. But yeah, that's what it takes. After you've done all this, I would suggest you try and clean up your code a little bit. Let's double check everything. And oh yeah, I'm actually gonna submit this into Qmk right now. But let me just double check everything first before I start committing and submitting. Yeah, I think everything looks good here. So I'm going to submit this into Qmk and hopefully it gets approved soon. And people will be able to use this on Qmk Configurator. did that. So what I'm doing here is I'm just committing using git, and once I have this all in, I'm going to file a PR. All right, got it all in. Push into my fork on GitHub. And let's file a PR. Why BootMagic Lite, by the way? So BootMagic is a feature in Qmk. Let me turn off my multimeter there. BootMagic is a feature in Qmk that allows you to hold space and B while plugging in your keyboard to drop into bootloader mode. And that actually just reminded me, this is not an atmel DFU, so I'm not going to file the PR yet. This is on a Teensy. No, this is on a Pro Micro. So good thing you asked that, because I remembered. But talking about BootMagic again, BootMagic allows you to press space and B while plugging in your keyboard, and it'll drop into bootloader mode. It also allows features such as swapping your control, your alt, your GUI around. So there have been some instances where people have BootMagic enabled, and they're like, how come my caps lock and control are swapped, and I can't seem to fix it no matter how much I edit my key map? That is BootMagic, and that is super annoying. That's what happens when you have BootMagic set to yes. So I personally find the only use for BootMagic is that space B feature. BootMagic Lite, on the other hand, changes it so that all those other swapping doesn't work. It's only the it's only the special reset key that you have to press. In Lite, that the default key that you have to press is the key located at column 0, row 0. So in our case, the key located at column 0, row 0 is this guy right there. Okay, so I was going to set this to, it's not atmel DFU, it's Katarina. So for those of you who have never dealt with the Pro Micro before, it has a bootloader different from most of the other boards. The preferred one is Qmk DFU, which is a variant of atmel DFU. Katarina doesn't actually check for, it doesn't check against the size of your firmware file. So if you made a firmware file that's too big and you tried to flash it on your Pro Micro, it would say, go on ahead. I don't care if I don't have room for it. I'm going to let you flash it and overwrite other important stuff that we need, which could brick your Pro Micro. So it's not fun, especially after you've soldered in a Pro Micro. Those of you who have soldered one in or have tried to solder one out, you know how difficult it is. So use sockets. So in case you do this, you can just pull out your Pro Micro. But Enemy's Friend 22 says, so that's basically if you don't have a physical reset button or don't want to use it. That's correct. I personally would prefer to use a reset button, but in some cases, like the recently released KBD67, the PCB has a reset button, but the case that it's sold in doesn't have a hole for you to access that reset button. So you need something like this in order to do it. Granted, there is also a reset key, which you can program into your key map that allows you to do the same thing. So, okay, we set to Katerina. Okay, thanks for asking that question because I completely forgot. Set bootloader to Katerina because Pro Micro. Boohoo. Yes, you are able to flash Atmel DFU or Qmk DFU onto your Pro Micro. If you want to know more, definitely drop in on our Discord channel. I've actually only used it on one of my boards, and it's great. Okay, did I push that? No, I did not. Super16. Yeah, I fortunately have not had to learn it the hard way, even though I've soldered my Pro Micro in. I've been really lucky so far, but I'm gonna stay away from Pro Micros. Okay, let's do that pull request again. Compare and pull request. New keyboard, new Macropad. 1upkeyboards Super16. Describe the changes in detail. Put a new keyboard into Qmk under the 1upkeyboards vendor. Okay, there's not much to say about that. Create pull request. It's a keyboard. Click. Nope, I don't need that. There we go. Okay, and I guess it will, if it passes, someone will see it and say, okay, your keyboard can go into Qmk. Once that's done, you'll be able to see it right here in this long list right there. All right, well, thank you everyone for joining the stream. I think tomorrow or maybe next week I'll actually be building this and using the code that we just wrote today. I don't have any Macropad, so this is actually my first. So yeah, tune in for a build stream. Make sure to check me out on youtube.com/mechmerlin. Follow me along on Instagram to get clues on what keyboards I'll be porting next. And if you would be so kind, I'm open to donations. You can make a donation at streamlabs.com/mechmerlin. Thank you all for watching. Hope you've learned something. Feel free to PM me on Discord, send me a message on any of those links that I mentioned, and I will try my best to get back to you. Thank you all again for watching, and good night.